Dobrý večer. Paul Lammertsma za námi přijel až z Nizozemí. Bydlí a pracuje v Utrechtu a je CTO ve společnosti Pixplicity. Paul je zkušený speaker, kterého jsem potkal už na několika konferencích a dnes vám poví něco o tom, jak provádět synchronizace na Androidu. Takže já předám slovo Paulovi a on už vám poví, co má.
Hello everybody, my name is Paul Lammertsma. I'm going to try to speak slowly because I'm sure that not all of you are native speakers like I am. So if I'm speaking too quickly, just raise your hand and I'll have to, okay. I'll just try to remember to speak slowly. I'm very bad at that because I'm an American and before I know it, I'm talking really quickly like this. And then you don't know what I'm saying. All right. It's really nice to be here. Thanks to all of the organizers for making this possible that I'm here today. I'm really excited to be here. I understood a couple of words, I think, what was said about me, that I am a conference speaker and that I am here from the Netherlands, which is correct. I am giving this particular presentation in my current conference season, and it's about synchronizing, basically, right? So accounts and account synchronization and data synchronization inside your Android apps. And I gave it this wonderful title. I've been doing some syncing. And I want to talk about that for a little bit. A little bit about myself. I am Paul Lammertsma. I am the Chief Technical Officer at a small company based out of the Netherlands called Pixplicity. And I really enjoy my job because I get to do these kinds of things, talking about things that I'm passionate about, and talking to people who are passionate about those things as well. So I'm really fortunate to be in this position, to be able to do those things. We do a ton of fun projects, but I won't bore you with that. Let's talk about synchronizing. So who here is familiar with the notion of SyncAdapters? Or show of hands. Okay, who of you have gotten that working and are really happy with that? Okay, that was of course a tainted question. Right, so SyncAdapters are this thing on Android that, well, I have slides for that. It basically assumes three things. So first of all, it assumes that you have some way of transferring data between the device storage on the app, basically, and a server that you basically have control of. It also assumes that your data is associated with some sort of account. So for instance, that you can log into your account using a username and password or using OAuth or something like that. Some way of basically logging in and representing a single user with an account. And of course also that your server stores some kind of data that requires basically some sort of login to be able to access that data, right? So I have a clicker, should use it. Right, so what the SyncAdapter itself actually takes care of is it takes care of the background execution of when data is synchronized between your server and your app when your device actually loses connectivity. And it also takes care of bundling sync operations between your app and all of the other apps installed on the user's device in a clever way. And I'll talk about that a little bit later on, but it is an important topic to, I think, address, because if you are an app developer and you respond, for instance, to the presence of an internet connection, if you immediately jump on top of that internet connection and all of the other apps do the same thing, then ultimately your user will have a bad experience. Okay, so this is basically SyncAdapter in a nutshell. Let's talk about what we're going to be doing in the course of these coming 40 or so minutes. You have a couple of learning goals, but I thought it would be fair for me also to have some learning goals. So your learning goals are going to be understanding the notion of the SyncAdapter and seeing it in practice. We'll also see two other related topics, which is the account manager and the account authenticator service. My goal is to somehow convince you guys, and this presentation was basically sold on the idea that it wouldn't just be about accounts, but it would also be about app architecture, so that the architecture of your app having a architecture like this is bad, okay? And that this architecture is way better. So that's going to be pretty hard for me to sell you on, I think, right? Because this looks pretty complicated, and this looks nice and easy. All right. Okay. So the ongoing example throughout these slides is this simple demo application. This application is actually part of Google samples. It's actually called the Sync demo. And I took that same example. I made some general improvements to it because, of course, it wouldn't be Google if it weren't buggy as hell. And I took that example and I improved on it, basically taking the modern approaches. This thing was a little bit dated. And you can fetch the source of that. It's on our GitHub, so I'll show you this. I'll show you the URL for that a little later on. In any case, what the application does is it basically has a very simple list containing all of the blog posts from the Android developers blog. And whenever you open this application, it basically fetches the latest data. So if we look at what's behind the screen, behind the scenes of this application, of course, it's ultimately some XML Atom feed. And Atom is basically just a sort of a blog notation in XML, obviously, of different blog posts of a blog. And it looks something like this, so you don't actually have to know how it works because that's just all included inside the demo. But it obtains this data from the internet, which is, of course, basically semantic data about the different blog posts that you want to display inside your list. And the trick here is, of course, when do we fetch this data? When do we present it to the user? That's, of course, the ultimate goal. And if we represent this in a different way, of course, we can see these two separate components as the UI, right, and the network layer. And, of course, somehow that network layer communicates with the internet. This is basically that first diagram that I showed you, right? So it just has two simple components. It has a UI and it has a network. And, the UI basically asks the network layer, fetch me this data, and the network layer responds with, here are all the blog posts, and provides it into a list adapter. Easy peasy, right? Super easy. This looks pretty straightforward, doesn't it? Yeah? If I represent this in a simple diagram, this gives me some room to point out all the problems with this. One of those problems, of course, is that there's absolutely no caching whatsoever. So each time that my UI wants to obtain data from my network layer, that means it has to ask the network layer, make this request to the Android developers blog, fetch that XML file, parse it, and provide me with a response of all the blog posts. So that's a bad idea, right? Agreed? Bad idea? I think so. I wrote it as bad idea number 1. I think it's the biggest bad idea. So that's probably something we can improve upon. The second bad idea is actually related. If I were to represent this in a different way, suppose we expanded our application so that it not only had, for instance, a list of all blog posts, but you could actually tap on a single blog post and bring up the details about that, right? That would mean that we have two separate UI components, and because we only have one representation of our network layer, the presentation of that blog post also has to go back to this network layer, request basically this single blog post, parse out the response, and present it in its own way. So the real problem here is that we don't have a separation of concerns. We don't have a way of presenting a blog post or interpreting the notion of a blog post and using a sort of a common way of representing this model, for instance, basically, and presenting it into different components within our UI. So these two things we can actually tackle in one go if we were to, for instance, introduce something like a content provider. And of course, a content provider is exactly what it is. It provides content. So in this case, our content would be a series of blog posts, right? And whenever our network layer fetches data from the internet, so from the Android developer blog, it inserts those blog posts in some, basically as a table inside our database, for instance. And it would insert it into our content resolver as a series of blog posts. So it would update our database with all our locally stored blog posts. This immediately resolves our problem of caching, because now we're performing caching. Because on the other end, on the top side of this, we can then query the content resolver for any blog posts that we have. And there's going to be some point inside our application where we say from the UI, hey, network layer, you have to obtain the latest blog posts. And when it does so, then it goes back into this process of updating our database, our local storage, and from our UI, we can then query that. We can make this a little bit better even, taking the same notion if we use something like a cursor loader, because if we use a cursor loader, we don't constantly have to query our content provider, because we have this wonderful thing called a content observer, which means that whenever the data changes underneath our content provider, we're immediately notified of changes in that. So for instance, if the network layer has, for some reason, decided it's going to obtain the latest blog posts, and it inserts those, the UI doesn't have to actually trigger a query on that. It just immediately gets the updated content. So we just immediately get in our UI the latest blog posts. Cool. There's a little bit of a problem with this, of course, in that the creation of our UI, so suppose the creation of our activity or the creation of our fragment, at some point we have to tell the network layer, of course, you have to obtain new data. And if we were to do that in the creation of our activity or fragment, that's, of course, going to be a one-off, basically, this is when you obtain the data, which introduces an immediate problem, because whenever your user opens your application, that means by definition, he's looking at old data. He's looking at the cached data. He's not looking at the most recent blog posts. He's looking at whatever blog posts he had downloaded the last time he used the application. So he opens up the app, he sees old data, you know, this trigger of fetching data is then executed. The network has some sort of latency, maybe the user has no internet connectivity at all. And only then, when the data is then actually fetched, it's updated into the UI, and then he sees, you know, the screen jumps a bit, new blog posts are added on the top, or whatever, however you want to implement that in your UI. And then he sees the most recent blog posts. So that's a bad user experience, because then the user is always looking at old data whenever he has this intention of seeing the latest blog posts. And the other bad idea is that what I briefly mentioned is this, of course, only works in your onCreate if the user has an internet connection when he opens the application. If he doesn't, then what's going to trigger fetching new data, right? Nothing. They'll have to close the app and open it again. Or you have to add some kind of refresh button in there, but that's not really sync, is it? That's not synchronization at all. Right, so we've already had 4 bad ideas. Let's see if we can fix this. We can. What I see sometimes, and what other developers do sometimes, I see them, for instance, introduce a broadcast receiver. You can, for instance, introduce a broadcast receiver that responds to the connectivity change event. This is an event fired from Android. Android basically tells you, hey, the user has a change in the state of his device's connectivity. And you can respond to that. You could do that inside your UI, but I think for simplicity's sake, we can just say, we'll introduce a service here, and whenever that connectivity change event occurs, we just directly invoke into our network layer a moment that we fetch that new data. Because as we saw before, whenever the network data is obtained, it inserts it into the content provider. This content observer then informs the cursor loader, and it updates the UI. So that part's already all squared away. That's all good. The service is basically our moment where we can actually respond to a change in connectivity. The user has gotten an internet connection, therefore we can download content, and therefore the UI is ultimately updated. So that solves a part of our problem. But unfortunately, this isn't all fixed, because one of the problems with this particular event, the connectivity change event, is that this event is called fairly frequently on Android. Imagine a user is on his way home from the office. He might lose Wi-Fi. Somewhere along his route, he loses his data connection. The data connection comes back. It's lost again. He picks up a Wi-Fi of a Starbucks along the way, loses it again. So if he's traveling, you'll see this event a lot of times. So that'll be triggering your broadcast receiver, which in turn creates your service. Your service is brought into life, which gives rise to a 6th bad idea, which is basically each time your service is brought to life, it has to do some sort of processing. It has to decide for itself, do I want to do synchronization? I just did it literally 30 seconds ago. Or if you don't take that approach, that you just download the data all the time, of course, that is the other side of the equation, that it's not CPU starvation. Well, it's also CPU starvation, but it's bandwidth starvation. So you're going to be using a lot of the user's data, probably when he doesn't want it. So if you're going to be downloading the latest blog posts each and every time this event occurs, then that's going to be a lot of data, a lot of requests, a lot of downloading this XML. You know, XML is quite verbose. It's quite sizable in this example. So how can we resolve this? Well, boy, do I have an example. SyncAdapters. SyncAdapters are the solution to all of our problems. What we can do with a SyncAdapter is basically use a moment from Android. Android will say, this would be an excellent moment to synchronize. The Android framework itself invokes your SyncAdapter, if you have registered it correctly, and it says, well, it's kind of more complicated than this, but if we just simplify things, if we just say, the Android framework says, hey, this would be a great moment to synchronize. And it will call your SyncAdapter will then do the network request, and then, you know, Bob's your uncle. Everything works. We've solved all the other problems, so this would be the final step of our equation, solving the sixth and last problem that we've seen. Okay, so I had a demo, but the demo is running on a different machine, and I don't want to give you all like epileptic attacks and stuff, so I won't do the demo. But let's just imagine, right? I fortunately included in the slides what the demo would look like. So again, this is the demo, right? So the demo, if you have an internet connection and you load up the app, and you could try this at home, you can just grab the demo. If you load up the app and you have a connection, it'll show up like this. It'll show you all the blog posts, and everything just instantly works. As soon as you open the app, the data is downloaded. Basically, the exact same principle as we saw in the very first slide. It does have a refresh button. This basically invokes a synchronization event. But what if you don't have an internet connection? Then things become fun. So if I enable airplane mode, then basically the app has no data to work with, right? That's perfectly acceptable. If you don't have any internet connection, then how could you possibly know what the blog posts are? So in this example, I've basically written this text that says waiting for sync. It just waits for an internet connection to come in. And whether you have the app open or not, and you disable airplane mode again, the blog posts will come in. And this is this magical part of the SyncAdapter. The SyncAdapter will be executed by Android in a moment that Android thinks is good for your application to perform synchronization. And the most obvious example is when you, as a user, have obtained an internet connection after a prolonged period of being offline. So if I were to sketch an example, suppose you have been on a weekend away to a foreign country, you didn't have data, and you come back home, and the first thing you do when you get back home, you're back on Wi-Fi, or you're back on your data connection. Android sees, hey, there's all of these applications that have to perform their sync operations. What Android will actually do is actually go one by one through all of those applications to perform synchronization in serial. So one after the other, the applications will get a window of opportunity to actually perform your synchronization and obtain this data. So that's great, of course, from a user's perspective, because that means his phone isn't bogged down with CPU cycles. His phone isn't bogged down by network requests that he has no network bandwidth to be able to do. I don't know, maybe he went on a weekend away, he wants to share some photos on Facebook. You know, that would be kind of a bad experience, right, if all of the applications were synchronizing at the same moment. So basically, that is a good story. The bad side of the story is, of course, for a demo, it always kind of sucks because I don't know when my application will get that window of opportunity to actually perform the sync. It'll just happen sometime soonish. So as a demo, this is actually easier to show it on slides anyway. Right, so it will ultimately appear. And the nice thing about this is this cursor loader also takes care of instantly showing our data as it's actually being inserted into our content provider. So I don't have to manually, I as a developer don't have to manually refresh this list view because my cursor loader is hooked into my content provider with a content observer. Okay, great. One other thing I wanted to mention about the demo is if you actually go into the Android settings, you'll see this option, Accounts. Has anybody actually seen this on their device? Accounts. Anybody seen that? Yeah, you've probably seen it, right? Like you can see like Facebook has it and Twitter and some other apps, they actually store accounts. And if you look into this list of accounts, you'll see all these different applications. And this particular application, this sync demo, also adds a new account for that. Now, this demo actually is not perfect to explain all of the different aspects of the SyncAdapter because it does not require authentication. Normally, what you would do with Facebook or Twitter or something like that, you log in with a username and password, you obtain an OAuth token, and you store that into the account list here. This application just fetches publicly available data. So it's not a perfect example, but we'll kind of see how we can still cope with that. There's one other thing that you can do is you can actually tap on that account. And you can actually, as a user, manually perform a sync operation, or you can remove the account from synchronizing altogether. So sometimes when an application is misbehaving, synchronizing too often or something like that, the user ultimately has control. He can remove that if he wants to. All right, let's proceed. Okay, so I was talking about synchronization events, but what actually defines a moment when Android actually performs a sync? Well, there are a couple of different ways of doing that. First of all, you can define a specific moment on demand. So a user can hit a refresh button. You can perform a sync exactly then. So a refresh button might be doing it. Another good example of when you might want to do that is when for instance, when a push notification comes in. So if a user receives a push notification like, hey, there are new blog posts, then you might want to use that as a trigger to actually perform a full sync and make sure that that data is actually available to him when he loads up the application. That might be a good example. Another good example might be if you are performing an actual read and write synchronization where the user can also generate content. For instance, in Facebook, if you're going to be writing a blog, a newsfeed post or putting an image or something on there, like sending a photo, that could be a trigger, of course, for the user for generating content that needs to be sent to the API. And of course, that's also a great moment where you can actually send data and then perform the sync as soon as that data is ready to go. Another moment would actually be what I showed you in the previous slide, when the user actually taps that Sync Now button. But probably what you would want to do is this last option, which is basically saying at regular intervals, let's say like once a day, or I don't know, once an hour, or whatever your application needs, that you would perform it at a regular interval and synchronize like that. Okay, so going back to this slide where I showed you all of the different components that we need, and I told you about the Android framework magically hooking into the SyncAdapter. Well, I lied a little bit about that, of course, because it's not that simple. The Android framework, of course, like anything on Android, can only interact with very specific components. So it can, for instance, launch an activity, or it can bind to a service, or it can send events to a broadcast receiver. And this is no different, of course. So the Android framework itself can only perform those tasks. And the SyncAdapter is no different. It doesn't have any special kind of rights. So we can't hook directly into the SyncAdapter. Instead, we need to introduce what I'm going to call here a sync service. So it's just a conventional service. The Android framework, it binds to the sync service, and your sync service communicates with your SyncAdapter. Now, if you haven't heard enough of the word sync, well, then I still have a lot of those words coming. What you can then do is basically register this manifest. We'll see that in a little bit. And one other thing that we also have to bear in mind is what I told you. In order to perform a synchronization on data, Android's SyncAdapter assumes that you have some sort of authentication on that. And for that, we need something called an account authenticator service. Even if you're not actually performing authentication, you need that thing. Believe me. We have three components that we have to focus on. And I'll strip them down. We'll go through them one by one. The sync service, well, before we actually start about that, let's just take a look at the manifest, what we need to get everything hooked in there correctly. Of course, we need internet. We also need a permission to be able to manually enable a SyncAdapter. We have to register that the first time we launch the application, basically. So if the user has no SyncAdapter registered, we can register this through this permission. So basically, we need to write to the synchronization settings in Android. And the other thing, which is very closely related, is in order for that SyncAdapter to hook into something, it has to have at least one account. And our specific example, where we're basically just communicating with a public blog XML feed, We don't actually need any formal authentication with a username and password, but we need some sort of representation of an account for the SyncAdapter to work. And therefore, we need to add an account for the user. And we just create an empty one, and for that we need this authenticate accounts permission. Right, so registering the service itself, of course, is no different than just registering any old service on Android. We just, in the manifest, register our service, and we have to give it some kind of instructions on how this service is launched. And for that, of course, we use an intent filter, right? So the intent filter has an action associated with it. Oh, one other thing, it does have to be exported because the Android framework has to be able to access and bind to your service, so it does have to be exported. And the action that we then provide is a action defined by the system called android.content.syncAdapter. We also need to be able to provide metadata into it because we have to describe how our SyncAdapter actually behaves. So Android needs to understand when we want to synchronize, for instance, or how it's presented to the user with the icon and the name and stuff and the Android settings. All right. So if you look at the content of the service itself, it's very empty. Basically, all that the service does is it creates an instance of our SyncAdapter, and that's basically it, except we also have to provide a binder. Like I said, the Android framework binds to our service, so we have to provide a binder. Now, fortunately, Android's SyncAdapter implementation comes with a SyncAdapter binder straight out of the box, so all that you have to do is reference that. So again, this field SyncAdapter, if I go back one slide, we'll see that this SyncAdapter is basically just a new SyncAdapter. And this class itself provides the method to be able to obtain that binder. So this is just all boilerplate. All right. So about the service itself. So of course, the service is launched by the system. Whenever the system executes this, this action, your service will come to life through this intent filter, right? And it's important to bear in mind that this service will live as long as it needs to perform the operations in your SyncAdapter. So the life cycle of your service will start and it will end with the duration of the synchronization process. Now, let's take a quick sidestep and focus briefly on the account authenticator service. Like I said, Android expects you to provide account authentication as a part of your SyncAdapter. The reason it does that is it actually plugs into the account manager. So the account manager in Android can actually store different kinds of accounts, and it can be extremely useful for you as a developer if you actually want to use formal accounts with usernames and that sort of thing, because that way you can very easily associate the synchronization of a single user. For instance, if you have multiple users, you can synchronize all of those users in series. And also actually providing the credentials for doing so. So the crappy thing about this, though, in our example, where we're only interested in performing a synchronization on a public API, is that we don't need authentication. But nevertheless, what this article from the documentation actually says is that you still basically need to register. So even if your app doesn't use accounts, you still need to provide an authenticator component. So that kind of sucks. So we have to go do this. We have to create this, basically this stub. And that's what I'm going to do in these coming slides, providing basically an empty stub. And it can be a great opportunity for you to expand on that if you need something else. But in my example, it was basically an empty class. So again, registering a service here, again, with an intent filter, a different action this time. It's called the account authenticator action. And providing different metadata that actually provides information about what kind of account authentication our application uses. The accounts authenticator service itself is very similar to the one that we saw before. Basically, we just create a new account authenticator and we obtain the binder from it. So again, just boilerplate, nothing surprising here. All right. Now, our account authenticator has to implement this abstract class called the abstract account authenticator. And since our specific implementation doesn't need to actually do anything with authentication, we can just implement our methods providing null, 0, or false wherever the methods are implemented. So I don't actually provide that in the slides, but you'll just basically see if you look at the source that they all just they either return null, 0, or false, whatever the required data type is. There is one exception to that. The add account method has, I kind of consider this a bug in Android. If you actually try to add an account through the Android settings for an application that doesn't support accounts, if you were just to return null here, your application will crash with a null pointer exception from somewhere deep within the Android framework. So to resolve that specific issue, here's a slide just for your reference. It basically returns an error code saying like not supported. Okay, moving on. Let's talk about what we were talking about with the metadata, the actual content of our account authenticator resource file. So it basically contains a couple of things. It says where our account preferences are described. It says, this is a very important one, this account type here. It actually defines a fully qualified name, something that we can kind of store that represents a singular account. So it's exactly that, it's an account type. So wherever you're trying to access your account from your application, you're going to have to provide the same name. The label, icon, and small icon are basically what are displayed within the Android settings in Android. So what the user ultimately sees when he's inside the Android settings. Now let's talk about the SyncAdapter. The SyncAdapter itself also has this metadata that we were talking about before in one of the first slides where I showed you the manifest file, which points to this resource file that describes our SyncAdapter. Now again, we'll see the same account type is defined here. So this is basically the connection between our account authenticator service and our SyncAdapter itself. So it knows which account it's using to synchronize. It has a couple of things here, allowing parallel synchronizations or not, whether it's always synchronizable by the user, so that gives the user the option to perform a synchronization manually from the settings. Has some other things, whether it's actually visible to the user or not. The only important thing to see here, I think, aside from the account type, is this content authority. Now this content authority points to something that would seem like it's a content provider, right? So does this mean that we need a content provider? Well, actually, yes, and I'll get back to that in just a second. So you actually need a content provider. So whether you're actually planning on using one or not, tough luck, you need one. All right, so what does our SyncAdapter actually look like? Again, it needs to implement an abstract SyncAdapter, which we call the AbstractThreadedSyncAdapter. And the name threaded suggests that it runs in a background thread, which is true. But the duration of the SyncAdapter itself, like I mentioned earlier, is ensured that the SyncAdapter service, so the sync service that I introduced earlier, that its life cycle starts and ends with basically the last synchronization event. So if you have, for instance, 3 accounts that you need to synchronize, they'll all be executed in serial or in parallel, depending on what you prefer in your manifest, in that resource file. But in any case, the service will start and stop with the final, with the termination of the final thread, so to speak. Now, what we need to do here is basically implement one important method, and that is this method called onPerformSync. And this is the place where you get the information that you basically need to perform the actual synchronization. So all of this stuff has basically boiled down to this singular method, right? onPerformSync. So you know which account is being synchronized. You know the authority to our content provider. And we have a reference to a content provider. It's not a real content provider. It's like a lightweight version of our content provider, but it gives you access to it if you need it nonetheless. And finally, it also gives you the intent, so whatever instructions the SyncAdapter was used to actually launch, you don't typically need that. And finally, it also provides you with an object that you can use to inform the platform whether or not your synchronization was successful. And that can be important because, for instance, if your synchronization failed for some reason or another, you can say to the platform, you can basically give it information about like I/O errors, and then the platform will take care of doing like an exponential backoff or something like that, so it doesn't try each time and time again, despite your API, for instance, being offline. So this sync result can be a mechanism for you to inform the platform that your synchronization didn't work. Okay, so like I mentioned, when does it sync? On demand and at regular intervals. How does that actually look? Well, I can show you a couple of snippets. Syncing on demand would look something like this. Here I have some method that I called trigger refresh. So that might be when the user, for instance, actually physically presses a refresh button. I provide a new bundle, and this is actually this bundle that we saw on the previous slide that comes into the on-perform sync. And we can provide some system keys into that. The sync extras manual to tell the platform that this is a manual sync, and that we want to perform it expedited, or that is to say that we want to perform it as soon as possible. And then we actually perform on the content resolver this method request sync. We inform the content resolver which account we're trying to synchronize, the content authority to our content provider, and these extras that we provided here above. Well, it's a bit of code, but it's fairly straightforward, I think. Syncing periodically is not actually executed through code, of course. Instead of through code, you actually provide through the when you create your account. So it's not a periodic event that you would, for instance, register. But when you create the account into the content resolver, you say to that, hey, I want to do a periodic sync, and I want to perform it on this new activity, on this new account that I'm creating, and the frequency is then provided. And I think this is somewhat of a gotcha here, because this poll frequency is all of a sudden in seconds, whereas the rest of the platform pretty much works in milliseconds. All of a sudden that's in seconds. So that can be a bit of a surprise if you're a factor 1,000 off. Might be a bit of a surprise. I speak from experience. All right, SyncAdapters. Okay, so like I pointed out, there are two important things to bear in mind here. The account type here in the SyncAdapter, and the content authority, which then references some notation to a content provider inside our application, which I hinted at earlier, also has to be registered. So also in our manifest is a content provider. So to the question, do we need a content provider? The answer is yes, because we're referring to a content authority, and that content authority is only defined by actually providing a content provider. So we need to actually provide one. And in order to provide one, we actually have to create one. So now we're like 3 steps further. In order to get the SyncAdapter working, we have to reference a content provider. In order to get a content provider working, we actually have to create one. All right, so we have to create one, but the good news is it doesn't have to do anything. So all we need to do is create this thing called, I like to call mine dummy provider. I think it's actually called that way in the demo, dummy provider. And again, all that I do is all of those methods, I just return with false or 0 or null, whatever it expects. So it doesn't actually insert anything into our content provider. It doesn't actually query or delete anything. It just exists. All right. And of course, the obvious improvement to this would be to actually store those blog posts into the database. So actually giving this content provider content, right? So actually defining in these methods, insert this blog post, right? And when a new network request comes in, you could also consider, for instance, completely clearing out the database and replacing it with all the new content. But for this example, it's just a dummy provider. Okay. All right. So yeah, so the sad icon over there, of course, because why do we have to do this? Well, just because. Deal with it. Right. Yes, one other thing that I wanted to point out was the account type. So I mentioned that we actually have to define an account type. And to me, whenever I have to do something that I don't immediately understand, my obvious question is why? Why do I have to define an account type? I don't actually have an account. I'm not actually using account authentication. Why do I have to define an account type? Well, the reason is because somehow in our synchronization, in our SyncAdapter, the way that it's presented in the Android settings has to be presented with a account, a single item in the list. And the way that we do that is basically somewhere in our application where we're registering our application for the first time to perform sync, we provide this account object. And this account object then has some name associated with it. That could be a username, for instance. But ultimately, it contains this account type. So whatever we define in the SyncAdapter in our manifest, we also have to provide in code when we actually register this to the content provider to actually register our application for synchronization. Now, beware of what we were talking about just a second ago about this account name, because when I think of providing a string, something that's user visible to the user, right? So some kind of string that is inside my application that's visible to the user, the first thing I think of doing is, oh, that has to be internationalized, right? That has to be a localized string. So for instance, in English, it might be saying something like, I don't know, Android developers blog posts. And in Dutch or in Czech, it might be something else, right? Well, beware of doing that, because if you do it that way, this is actually the unique representation of your account for the platform. So if you give it one name in English and the user changes his device locale into Czech, for instance, then it'll have a different unique identity. And then all of a sudden it'll have two synchronization accounts. And that might not look bad, but that means that Android is synchronizing on two different accounts and is executing your SyncAdapter twice. It's executing the method onPerformSync with that first account name and that second account name. So it might actually give rise to problems, and not something that you would immediately think of testing either. So I emphasize that that account name should not be localized. It doesn't really matter how it presents to the user anyway. He probably won't see it. Most of you don't even know that the account settings screen exists. And besides, if you're doing a proper synchronization like Facebook or Twitter, you'd be using a username after all, and that's not localized either. All right. So let's recap a little bit. SyncAdapters can be used to fetch background data for an application. It can be used to actually perform. It can be the trigger moment in your application where it actually executes the logic for performing the synchronization. And you as a developer can configure that for specific intervals, or you can perform it when you want it to. And those good examples of moments where you would want to provide the user a manual refresh moment might be through a refresh button, so that he can rest assured that he's looking at the most up-to-date data. Or it might be something that responds to, for instance, a push event. So your API might send a push notification, then you can respond to that by synchronizing all the data. And the nice thing about this is that Android will take care of doing it efficiently. So you don't have to be concerned about when do I need to perform this. You know, you don't have to be writing out the logic for, well, I synchronized for the last time 5 minutes ago. I don't need to do another sync. Android will take care of that for you. So it won't spin up your service. It won't perform on sync, so that you're actually performing network operations. So it's battery efficient, and it also conserves other system resources by making sure that different processes that are also registered as SyncAdapters are executed in serial. And more recap here. So what are the elements of a SyncAdapter? Well, we saw basically that it consists of three primary elements. The AbstractThreadedSyncAdapter, which is our implementation of the SyncAdapter itself. And the two services that the OS actually binds to, that is the sync service itself, which then executes our SyncAdapter, and the other one, which represents our account authenticator service. And both of these are, of course, registered in our manifest file. And then finally, those two resource files that we actually provide as metadata for the sync service and the account authenticator service. Providing information about respectively our sync adapter, of which how it synchronizes, whether it performs in parallel, which account type it's trying to synchronize, and the account authenticator itself, which also references the account type, but also provides some other data of how it's actually represented, displayed with a name and some iconography and stuff like that in the account settings. There is some bonus material. I just don't know how I'm on time. I'm over time, aren't I? Yeah, that's a yes. Okay, I'll skip this. There is some other material. You can also find the slides on the GitHub page, so if you're curious about that, you can also check it out. Yeah, there's also, here's the authenticator you can also provide some settings into that. I'll just skip over that. It's basically this picture. So you can also, for instance, allow the user to have some preferences here. I think this is kind of useless because the discoverability of this is next to none. Like maybe 1% of your users will figure this out. So I would say don't bother, but it's possible. Okay. A colleague of mine insisted that I included this slide because the approach that she always took was using a job scheduler. And she said, well, why don't you just use a job scheduler? And I said, that's a fantastic point, but it only works on Android 5.0 and later, and with Doze mode, only on 7 and up. So the battery efficiency of this is only really guaranteed, I think, on Android 7 up. So if you want to have your application performing synchronization events for older devices, SyncAdapters are definitely a way to go. And the other thing that Job Scheduler does not take care of is making sure that only your application is performing sync. So what you can do is you can be a bit more granular in when you want to perform a sync. For instance, one of the things that you can do is you can say, like, I only want to perform a sync when I'm actually charging. Yeah, so there are benefits and disadvantages of each. And I, of course, feel absolutely required to mention that Firebase is, of course, also an option. If you have full control of your own API, and you can say that instead of a conventional RESTful API, or an approach like with this XML file, it's basically downloaded each time. If you have full control over your API and you can decide, for instance, for a real-time database, that you actually perform push notifications each time that data changes from the API, Firebase might be a better solution for you because you don't have to be concerned that the synchronization only is performed once every 24 hours or something like that. It basically is whenever the user has connectivity. So Firebase is, I think, at least worthy of mention. You can find the slides and the code on our GitHub page, pixplicity/syncs-demo. And that's pretty much it. That wraps it up. Thanks so much for listening. Okay, we'll take a few minutes for questions. Questions? Oh, come on, there got to be some questions. This is like a really weird and confusing topic. Huh? Oh. That's all right. Any questions? Yeah. Okay, I didn't know that. Okay, so David, thank you for pointing that out. David points out that the job scheduler is actually included in Google Play Services, so it's actually backported to older devices. Okay, cool. I did not know that. Oh yes, I remember that now. Yes, GCM Network Manager is the name of the. Yeah. Right. So everything is becoming Firebase, right? Okay. Yes, that's an excellent point. Yeah. So I can kind of combine those slides now. Okay. Cool. Thanks. Anyone else? Oh, wow. Can I use a SyncAdapter without a need for an account in it? No. No. Unfortunately, that's not possible. So regarding this second question here, can I use a SyncAdapter without the need for an account in the system settings? Unfortunately, no. Not as far as I'm aware, at least. The reason for that is that the SyncAdapter is invoked through the provisioning of a account type. So the account type defines what is, well, I don't know exactly the mechanisms of it, but the account type is basically the most determining factor of what performs a synchronization. And as a result of that, you have separate accounts that are then performed for the onPerform sync. So even if you didn't need the account type in itself, your onPerform sync would never be executed because it is by definition executed per account. So you need at least one account. And if you have 2 accounts, then it's performed for each account, right? So if you have multiple accounts, then it's performed for each account. The third question here: how do sync permissions work with permission model of Android? It's not a runtime permission, so you can just define it once in your manifest. It doesn't actually perform. It doesn't bring up pop-up, as far as I know. I just ran this exact same demo on the latest Android 7.1, I think, on the emulator, and it doesn't bring up any runtime permissions. What if a user disables synchronization in the account settings? Can the app prevent it, or will it recover from it somehow? No, then it will simply not work. Android is very, in recent years, I would say, Android respects users' preferences first. So if your user has specifically selected not to perform sync, it won't perform sync. You can't, as far as I know, you can't even detect it. Maybe it's possible to detect, and then you can present to the user that he has disabled sync, and you can show it in the UI of your application. That might be possible. So that might be a potential resolution for you. Yeah, you can perform the manual sync. So in the case of the sync demo, you can hit the refresh button. That will run, but the periodic sync, that's basically what you're disabling. Is there support for periodic sync, or do you need to trigger sync manually by alarm? No, it is, as I illustrated. It is definitely supported periodic sync, so that's just basically define a synchronization interval. Does SyncAdapter support Doze? Oh, that's a great question. As part of the framework, I would assume that works out of the box. I wouldn't. What do you think, David? Think so? Probably, right? I would think so. That would break everything for all of the applications if SyncAdapters did not work with Doze. So I would assume so. Bear in mind that the sync adapter is basically you don't have to be concerned about what are the preconditions of what invokes the synchronization event. All you need to do is respond to the onPerform sync method and actually implement the synchronization logic in that place. So let's continue with the next. Is there a library I could use instead of writing such an amount of boilerplate? Unfortunately, no, not that I'm aware of. I am very doubtful whether that's even possible, solely based on the amount of specific information you need to provide as manifest data with resource files. Not that I'm aware of. And finally, is there a specified format for the account type value? Can somebody hack my app by using the same value, and what would happen if that was the case? That is a fantastic question, actually. The specified format, I don't think so. I think it's just by convention that it's preceded by the fully qualified name of your application, followed by some account type that you define. I think that's just the convention. I don't think that's required. I think it is controlled by the signature of your application, but I'm not actually sure about that. I would encourage you to figure that out and tweet me or something, because I would definitely want to know if that's possible. I think no, but I don't know. So figure that out. All right. Any other questions from the audience? All right. Then I'll hand it over to the next speaker.